that today we were going to talk about three things: resonance, polyatomic ions, and the diatomic elements. Okay? So we're going to talk about those three things today, and we're going to start off our discussion with resonance. Resonance. The biggest thing that I want you to be aware of when we're dealing with resonance is that we cannot write a single Lewis structure to represent the molecular structure. And you're going to see how we represent it here when I pull up the next slide. But we cannot write one Lewis structure to represent that molecule. Resonance instead considers such molecules to be an intermediate or an average that we call a hybrid between several different Lewis structures. So we cannot write one single Lewis structure for the particular molecule. As I turn to the next slide, you're going to see one of the more common ones is ozone. Where have you heard about ozone? Okay? Rachel, where have you heard about ozone? The ozone layer in our atmosphere. We talk about, what is it, CFCs that are depleting the ozone level, and they were thinking that more harmful rays from the sun are being let in to the earth because of the depletion of this ozone layer. However, what is ozone? Here we go. Ozone is O3. O3. Now, when you see a double arrow like this in between two different structures, that indicates resonance. Okay? What's the difference between this structure and this structure? Can you see the difference? What is the difference? What is the difference between this one and that one? The location of what? The location of the double bond. Excellent. This is in between these two oxygens. And if you look over here, the double bond is between those two oxygens. So when you see these dotted lines on that, that's also representing resonance, that double bond could be at either one of those particular places on the oxygen atoms. Now, another common one is when we deal with a benzene ring. We deal with the benzene ring, and that looks like this, C6H6. And if you notice the same things here, the double bonds are here, here, and here. If we look at the other one, they're in different places. So the double bonds have changed. They've went to different places. We cannot draw just one single structure to represent those because they're in resonance. Notice the double-headed arrow also. Notice the double-headed arrow that we can see that is representing resonance. Okay, so benzene is yet another common one. And I'll give you a couple of seconds if you're writing down benzene. Diatomic means what? What's di? Two. Okay, so two atoms. These elements are always diatomic molecules. So we find them together as a diatomic. And we call the diatomics the Super 7. The Super 7 is the nickname that I give these. So you might hear at times later on when we're dealing with writing out chemical reactions, I say, oh, we forgot one. Look at that. Okay? Chlorine is a Super 7. Okay? And that just simply means that chlorine is a diatomic molecule. So when we talk about the Super 7, we are talking about elements that are found in their elemental form as diatomic molecules, which just simply means that these are two atoms joined together by one or more covalent bonds. that form a molecule with the general formula X to the subscript 2. X to the subscript 2. Now, why do we call these the super 7? Because there are 7 diatomic molecules, and here they are listed. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Ladies and gentlemen, the super 7. Another fabulous thing about the super 7. Number one, there are 7 of them, but if you locate these guys on the periodic table, okay, and I'm just going through the different ones, and notice some of them are single bonds, some of them are double bonds, one of them is a double bond, one of them is a triple bond. Okay, so oxygen's double bonded, nitrogen's triple bonded. But if you locate these on the periodic table, here helps you out with the super 7. Look at this. What is that? Okay, what is this right here? What does it look like? A 7, doesn't it? A 7. What number does it start with right here with nitrogen? Number 7. Okay? Bunch of coincidence here. There are 7 of them. They start with number 7, and they make a 7 on the periodic table. You also got to include this guy over here, hydrogen. Okay, he's a kind of outlier here. But nonetheless, there are 7 of them. They make a 7 on the periodic table. They start with 7. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. The super 7. The super 7, the diatomic molecules. Now, finally today, we're going to discuss our last topic, and that is polyatomic ions. Polyatomic ions are also known as, aka, molecular ions. Now, if something is an ion, it has either gained or lost electrons. We have cations, we have anions. Well, we're going to have polyatomic cations, we're going to have polyatomic anions. And what these simply are is they're molecular ions. They're a group of 2 or more atoms that are covalently bonded. Once they covalently bond together, they have either added or lost electrons. Okay? It explains here a little bit further that the Greek poly means many. Even 2 atoms are considered to be polyatomic. Okay? Even 2 atoms that form an ion are considered to be polyatomic ions. Now, if I look at the very first one here, this is the nitrate ion. Okay, the nitrate ion, NO3 minus 1. Now, we're not going to have to deal with drawing these. Okay, I'm going to show you how they covalently bond together in the next couple of slides. But if you look at these right here, folks, if you look at these, oxygens have 6, nitrogens have 5. I have grouped those in that order, and what I mean by the dots, I have put the dots in this order because I know how these bond together. Okay? I know how these bond together. It's not necessarily important for you guys to understand the bonding because it's pretty deep. We're dealing with coordinate covalent bonds. Okay, that's more of an AP thing that I would imagine you would cover in AP chemistry if you take that next year or the next year. Now, as I look at this bonding, this is what happens. Okay? This is what happens and how the bonding occurs. Notice the red right here. the red electron right here. I have black electrons representing the 5 of nitrogen. All of the blue circles are representing the electrons of oxygen, but we have this one red one here. In order to obey the octet rule, we had to gain 1 electron. Okay, we had to gain 1 electron. So when we did so, we created this polyatomic ion. Now, when we talk about bonding, and I guess let me not get ahead of myself, okay? But if we look at this nitrate right here, these are covalent bonds, sharing of electrons. So we are sharing electrons. All simply a coordinate covalent bond is, it's this one right here, in which nitrogen is donating both of the electrons that are being shared. So that nitrogen's just being really, really, really nice to that oxygen, because he's not getting a whole lot back in the deal of letting oxygen use those 2 electrons. But nonetheless, oxygen then obeys the octet rule. So that's a really, really nice nitrogen atom right there. So that's a coordinate covalent bond. Now, all that this is just simply saying, and I don't know if you need to write that down, is that this whole thing, and that's why I've got it bracketed, okay? This whole thing right here, you see the brackets, this whole thing has a negative charge because it has gained 1 electron. It has gained 1 electron, so that entire complex has a negative charge. Well, if we look at this right here, what likes to lose 1 electron? Something like an alkali metal, correct? Sodium here, sodium is an alkali metal. So could sodium give his 1 electron there? Absolutely. So now what we are talking, we just said that this molecule is covalently bonded, right? So the polyatomic ion is covalently bonded, and then it is also ionically bonding. So when you see on a WebAssign, they're going to give you questions. And it's going to say what type of bonding is involved here. If you have a polyatomic ion, you have both, because it will ionically bond with sodium right here. But these are all covalently bonded. So when you're dealing with the polyatomic ion, you have covalent bonding occurring also with ionic bonding here. Now, I think we're about out of time, so we might discuss covalent bonds a little bit next, or when you come back here later today. Okay, but that's all I got for you right now.